But you have to explain what you're doing.
So this one here is just what's given. She's just writing what's given.
Okay.
So the power series.
The power series. Okay. What do you want to write on the other side?
You can write the solution on the working.
Oh, okay. So you're going to put there the power series, and you're going to start using the power series. Okay, right. Perfect.
I'm gonna have problems.
It's okay.
I've had problems.
I couldn't help but notice Claressa's writing is going in ascending order, like some angle of elevation. It's just an observation. It doesn't mean you're wrong. How did you get that? I don't know. So why didn't you write a statement from the expansion of exponential x?
I just put this one as x.
I know, that's what I'm saying. So you should write like from the no, just write it here. From the expansion of exponential x. So we already have the expansion. Means this is here, this is here. Why? Why didn't you just sign x here? Come on, make it neat. Make it neat. Yeah, this is OCD, right? Good. Yeah, I'm OCD too. Yeah, that's better.
Okay,
so we know where you got that from.
Okay.
If you have not done it, I need you to pay attention to what they are doing and ask them questions. If they are not able to tell us what they are doing, we're going to get them arrested.
What? Okay, bye.
That's just enough. You don't have to like write more than that. No, I'm not talking to you. I'm talking to
Oh,
Claressa.
it would make more sense to write two sentences.
Oh. No. It's like I didn't know like when we expanded it. I don't think so. So just write the power series.
That's important because
It's actually more.
continuous. Yeah. Okay.
How do I explain this part? Like convert. Just continue.
Open the brackets.
Yeah. You don't have to write open the bracket. We know you open the bracket.
Continue. Yeah.
Just continue.
I just.
But the first line is important because you need to tell us where you got that from. Is it possible to like? Is it possible to do it without looking at the paper?
Yeah.
Yeah. So
So,
the paper out. Because if I give you this in a test, for example, and you are relying on paper now, yes, miss.
What's the next one?
I squared.
Oh yes,
So
this is
then
another
one
one.
sentence.
Yeah, later.
Then
Okay.
Goodbye paper. Bye paper.
Goodbye paper.
Goodbye
Yes.
paper.
I don't really remember.
And you seem to be talking to yourself alone. You're not talking to the class.
Ooh.
I'm your student. I don't know what you're doing, professors.
Then you guys do explain. I continue right.
So we open up the
Class, do you understand what you're doing so far?
Yeah.
Yes, good.
Okay.
Okay, your students are getting it. That's fine.
I'm spreading bacteria to the whiteboard. What's the pattern? Okay.
And then you
I want to get a mixed race.
Well, this side. Yeah. And then minus O square, right?
You're talking to the whole class.
I'm sorry.
So I don't know where that minus come from.
you open.
Can you write it down?
right.
No. You don't.
I squared.
So just no. After the line, you can. No. It's all right. I squared is there. So minus is fine. So once you write your dot, then you can tell us why in a bracket somewhere. So continue, but just make sure you explain
Okay, I
why.
explain later.
Yes.
I forgot the
You can always put it here. You can always work it out here. What is I squared? What is I to
Yeah,
power 3? What is I
on
to
the
power
side.
4?
I'll do that on the side.
Yeah, okay.
Go, I'll write the pattern.
Okay.
Besides, Colista, let me give you a trick.
Yeah?
I square is -1, right?
Mm-hmm.
So any one you do is just multiplied by another I. So if you have a -1 times I, yes.
It's just
Yeah.
plus.
And that's the pattern. It continues. Look at the loop. Look at your right hand side. Ta-da. average.
This is average.
6.
I need you to focus on what they are doing. I don't think you guys are listening or looking at what they are doing.
It's plus.
It's plus, plus, minus, minus, plus, plus, minus.
I cannot. It's plus minus. What?
Yeah.
Okay.
It's getting
Dot, dot, dot.
You should not never forget that. It's a continuous.
I know.
Okay.
Wait, so for the last one, is it plus or minus? It's minus, right?
Yeah, but
Minus.
minus I at the top there.
So why do you have minus? Okay. Thank you, Leo, for that. You're gonna have minus and minus. Don't confuse the whole planet.
Yeah, there you
So this is what I mean. So you can now put in brackets because I square is -1, I cube blah blah etc. But we understand. You don't have to put that here.
Okay.
Does everybody get that?
Yes.
Okay.
Then it's just rearrange it, just so we collect the like terms, have them at the same side.
Some of you are not paying attention to what they are doing, and you probably think, oh, I get what they are doing, blah blah blah. Until I give you the test to prove that, that's when you know you don't understand what they're doing. What is she
Wait,
doing?
what are you doing? What
What are you
are you
doing?
doing?
So remove I on the side.
No, just rearrange it, because this looks confusing.
Yeah, it is
Just
confusing.
so it's like, no
Just
I
collect-
on the left side, I on the right side. Just do that.
So should I just put on?
No, move it around, okay,
Okay,
okay.
go, go, I get it. Because this is what I do.
Why?
I understand what I do, okay? That's what I do.
This
Yeah,
minus
yeah.
this.
So which one are you putting? What is your criteria for?
We are putting the ones without an I at front here, and then the ones with the I at the back.
That's what we want to hear. So someone who doesn't know what you're doing, that is the explanation you need to give me. Not just write everything on the board and we don't know what you're doing.
Yeah.
Uh,
I like term.
no, it's okay. Just rearrange. It's fine. Yes.
Then
Is that the end of those ones?
minus dot, 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 dot.
Yes, because even those without I continues indefinitely.
Yes.
Then those with I, good.
Then maybe you want to write factorize.
Hmm,
Then we factorize.
good. Division of labor,
Plus,
right?
plus, dot, dot.
I'm sorry.
No, factorize I, you can write your I on the same line, please. Yes, so she has space. Okay, great. So is equal to,
Do you
continue.
want me to just copy this again, or can I just skip it at this
Copy.
stage?
Don't skip. Don't be lazy. Come on. Lazy girl. If that is the way I skip, you may not understand some things in this class.
And then you, if it's the question asks for sine theta and cosine theta, so here it's for yeah, and then
Please
From the
focus on what
expansion
she's
of
doing, please,
yeah, from
in
expansion.
case there is anything wrong.
Next.
Okay, she remembers that. So what do we do next?
And then from
Tell the whole class.
from the expansion of sine x,
Uh-huh.
instead of x we use theta because that's what the question asked for. So we expand this.
So will you expand what?
Sine x first.
You're not expanding it.
From the expansion.
What exactly are you doing? Yeah, you're not expanding it.
Replace.
You're replacing it. Why are you replacing it?
Because from the question we want sine theta.
I know, but why do you need to bring it in now?
Because we finished separating this.
Okay, so does it mean if I finish up anytime, please wait, can you wait? If I finish, I just needed to defend what you're doing. What you're doing is right. So, as someone who doesn't know anything, he just said, oh, because I finished, so I'm going to bring in sine. So if I finish in third line, doesn't mean I bring in sine. There must be a reason you're bringing in sine and cos. Yes, sir.
Because it looks the same.
That's the simplest.
Okay.
Because at this point, it looks like exactly this, the expansion of sine and cos. It doesn't look like it's here yet, that's why you didn't bring it in. I may decide to say, oh, this is where I finished. Doesn't mean I can bring it in. So because at this point, it now looks like the expansion of sine and cos. So you replace it, period. Okay? Yes, proceed.
Do you want me to like do this thing I did yesterday?
So it's equal to, so the first part is what? The first part is what?
On the left is cosine.
Cos theta, so you just write cos theta is equal to cos theta. Yeah. Equals to, please. Then, yes?
Another equal sign.
No.
Just now?
You're just replacing it. Just tell us what this means in summary. Should I, wait, listen. This line, what will it be?
Okay.
Yeah, that's it. The meaning of the equals to is to say this line is now going to be the same as this. Alright? And this is all you are asked to prove. So what is your summary? What is your summary now? What is the conclusion? What have you done?
So just e power
Mm-hmm.
I theta equals to cos theta plus I sin.
That's it. That's what you have decided, what you have done. So it means when you have your complex number in polar form, you can write it in form of exponential. You remember, this is the polar form of any complex number, right? So it means you can now write it in this form.
Okay.
What is that form?
This is the Euler form.
So
Okay, we don't call it Euler formula actually. You just say Euler form. Okay. Okay. So remember, we are talking about how many forms of complex number have we talked about now so far?
Cartesian.
Cartesian form, polar form, and now we have the Euler form. So if, for example, I ask you to find the power of a complex number, say a complex number, give me a mark. So let's say a complex number z, please listen, equals 4 plus maybe 3i. Okay? And the question is asking you to find out what is z to power 1000. Are you, because now you know binomial expansion, are you going to expand this in binomial form? No. When you add the knowledge of the polar form, if you can express this in terms of some z, yes, remember? Then cos ci, I just use cis. Okay? I don't know, when I say cis, it reminds me of Chile International School. Anyway. Now, and cis theta, so it means this number can be in this form, right? So if I'm looking for power 100, I could say everything here to power 100. Right? Now this is not a problem because it's just a number. Worst case scenario, I leave it in index form. So it might be some number k, which is positive, to power 100, then cos theta plus I sin theta to power 100. This also looks like binomial expansion. But with Euler form, you don't have to worry. Can you see that? This is ei theta now to power 100. Do you understand? Because we have just seen that this and this are the same. So for simplicity, I could write this in this form. And by indices, what is this? E to power what? 100 I theta. And if you want to take it back, now, you were told that apart from I, anything else is your angle, right? Right?
Yes.
So, can somebody tell me e to power 100 I theta in terms of cos and sine?
Cosine
Cos
100
100 theta.
plus
That's it. So this Euler form allows you to express this easily. That's where we are going. So different forms can be, the first form is limited because it hinders us to perform some operations. Now we are in the polar form. Polar form allows us to do some stuff, but it might also be hindered. Now we have the Euler form of complex number. Does it make sense? And this is a bit late to De Moivre's theorem. As time goes on, we will see that. So can I please ask us to write this down in our notes? Thank you to the group.
That's right. Don't get the assignment. No.
What happens if theta is equal to pi? Guys, if theta is equal to pi, what will we have? E I equals What is this? What is cos pi? Check, come on.
0.
0. Are you sure? Negative. What about sine pi? 0. So what does that say about EI pi? Equals what? Negative 1. This equation is said to be the most beautiful equation in math. For whatever reason. Oh, pi. Do you know why? It makes use of three important constants in mathematics. The exponential, the I itself, and pi in one equation. In one equation.
So uses pi, uses I, and uses what?
Exponential.
And that makes it amazing.
Yeah. There is no other one that has a numerous constant like that. And it's very simple. EI pi plus 1 equals 0. Beautiful, right?
Yeah.
Anyway.
I can get a t-shirt with that.
Well, yeah, now that you said it, I should get a t-shirt. But this is one crazy thing I was going to do later. What did we say sine squared theta plus cos squared theta is the last time? 1. So I was going to get a ring where one of them would be mine and one of them would be that of mine.
Oh my god.
So inside the ring would be embedded sine squared theta, cos squared theta.
Who's sine, who's cosine?
Well, I don't know which one is more of male or more female. I'm going to have to find out. I don't know.
More of a sine.
So inside the ring will be sine squared and cos squared, and both of us will have those. So when it is large, then oh, this must be some couple because the combination of these two should be 1, right?
I don't think people can understand that.
Yeah. Well, they don't have to. You're not doing it for people to understand. Well, it's still something I should do, right?
You get custom.
As long as your wife gets it, then yeah.
Yeah, she will. I will do something like that without
Make sure
my
she
wife.
understands the joke.
Of course she knows. She knows how weird I can be. I'm ordering something on Amazon and I should place my order.
That's kind of like how I
It's
say
a hoodie mat. Like everything is math equation hoodie.
That's like how I said happy birthday to Ruben last night.
Really?
Yeah, I was like, I did something like I squared is -1. So at first I was like happy 18th birthday. And then at last I put something like something related to I squared, and then you add it back to the number. You get 18 minus 1.
So maybe
just kidding, happy 17th birthday.
Yeah, that's true. If this is like -1, the happy 18 plus this birthday, so that's 17, right? Anyways, beautiful. Right. Now this is just an identity. It's not the Euler form yet. Now the Euler form is to rewrite the complex number using this identity proved by Mr. Euler or Professor Euler, as the case may be. Leo, can you check if this part of the board is captured? Thank you.
Wait, this is how long ago, man? Like
What?
When was this invented?
Some centuries ago. I don't have the exact.
Whoa.
Now, are you here?
Yes.
Thank you, sir. So, from our previous knowledge, from polar form of complex number, z equals absolute value, or maybe we start from here. So now we know from z equals a plus ib, which is the Cartesian form. We already know that our z can also be written as the absolute value of z, yes? Then ci s theta, and this simply means absolute value of z cos theta plus I sine theta, yes? And now, from what we have done, it means this can be replaced, okay? Now we can see that our z can actually be written as absolute value of z exponential I theta. This is what we call the Euler form of a complex number. Because this is about z. That's not about z. That is just some identity between sine, cos, and exponential. Does it make sense? So again, this is your Cartesian form, this is your polar form, and this is the Euler form of complex number. So let's see how that can be used. There is also something I asked you to prove last time. Maybe I should have even started with that. Remember the equation I wrote on that part of the board? Multiplying two complex numbers?
Yes.
Did anybody do it? Krista, did you try it? No? Well, that's the answer, but I don't know how you got it. How do you get it? That's the answer, but you didn't show me how you got it. Okay, from last time, remember the question I wrote, this was the last thing we're supposed to do. Okay, so maybe before we apply this, we can look at the last, the correction number 2. From last lesson also, I asked you to, what was the question? If I may. I call it product of complex numbers in polar form. Do you remember the last thing I wrote on the board? I asked you if z is something and w is, z and w are complex numbers. So z is absolute value of z ci theta, and w is absolute value of w ci theta. I ask you, can you write ZW in polar form? Let's try to write ZW. ZW will be Z times W, right? Which will be, tell me what to write first. Let's do it together, and you know. So absolute value of Z, yes? No, this is actually phi, not, they don't have the same argument. Okay? They have different argument. So Ci S theta. Okay, oh no. Maybe I didn't get enough sleep, right? Okay, please, I need attention. CIS theta, yes? Multiplying absolute value of W, CIS phi. So, what do we do from here?
You can rearrange it.
Rearrange it.
So absolute value of Z.
Absolute value of Z.
Times absolute value of W.
Absolute value of W.
CIS theta.
CIS theta.
CIS phi.
CIS phi. Does that make sense, everyone?
Yes.
So, what does this become?
Absolute value of ZW.
Absolute value of ZW. Why?
From the properties of
Or the property of absolute value, right?
Okay.
CIS
CIS
theta plus phi.
theta plus phi. And how do we get this one?
Properties
From property of
CIS.
the CIS. We had about 3 properties on CIS. And this, for example, you may not even combine them, because for you to do that, it means you have to first multiply the complex number to get the absolute value. So this could be left in this form: absolute value of Z times absolute value of W, then CIS. So what does that tell us? If you need to multiply 2 complex numbers in polar form, what does that tell you? The product of 2 complex numbers in polar form is the same as what?
The two angles together.
2 angles together. What does that mean? You might be right, I just need to explain what you mean. You have to. Yes, anyone else? Because the last question I asked was what? The last question, what did I say? What do you notice? So class, what do we notice? Quickly. I need everyone on this. What do we notice?
The product of the absolute value of Z and the absolute value of W and the CIS of the sum of their.
It's not the CIS now. So when you have 2 complex numbers and you wish to multiply them, all you have to do is multiply what first? The absolute values. Then what happens to the argument? You had the argument. So you are increasing the argument by addition, then the absolute value is being multiplied, and that gives you the product. So that's the observation we can see. Okay? For any 2 complex numbers. So let's take note of that. And that was the last thing that you should do. So let's write it as a note. To multiply any 2 complex numbers, in polar form, we multiply their absolute values and add their arguments. Okay? What will be the case of division if you want to divide any 2 complex numbers? You minus the arguments and you divide the absolute value. So similar principle. Okay? You alright, sir?
And then I can have sleep.
Uh-oh.
I was studying English text.
We get like a 5 minutes break between 2.
Okay, so we want to have it now? It's not break time yet, but I can have
Then I
I
can
give
wash
you the
my
break
face.
now. 5 minutes, everybody. Okay.